To our webinar, Qualification of Dissolution Testers, USP Performance Verification Test PVT. My name is Jan. I'll be one of the moderators hosts for today, and welcome to our webinar. I would like to welcome our speaker for today is Alex Viechter. Just to give you a quick information on him. So Alex's career includes 7 years of experience as a pharmaceutical quality control chemist and 8 years with the Sotax Group, working as a sales representative and then as a sales manager for Europe Asia Distributor Market Business Unit. He has been with us at USP since 2005, and he helped establish the first international office of USP outside of the US, which was here in Basel, Switzerland. So ever since he has supported USP customers on technical and commercial queries, organized regional user forums and educational courses, and provided guidance to collaborators on the up-to-date monograph program. Since 2020, Alex has a coordinating role with the team covering EMEA, Europe, Middle East, and Africa, overseeing all sales supporting programs. So welcome. We, just to give you some agenda outlines, we're going to start. It's going to finish in 1 hour. We're going to have a 10 to 15 minute Q&A session at the very end. Please, when you have a question, select the Q&A box, which should pop up on your lower right half of your screen, where you can type in your questions, and they will be fielded by our co-moderators today, Mihail and Christian. We do ask you when you write your questions, please to write them in full sentences, and please write them that they make sense so that we really understand what it is that you're asking, because unfortunately we will not really have a time or opportunity to ask you to clarify that question again. So please try to write those questions in a clear manner so we can fully understand them. We will have a very short survey at the end, so if you'd be so kind to just take a minute or two to fill out that survey for us. To give us your honest and truthful feedback. We really appreciate it. It's very important for us, and it will help us to build a better experience that you have with us here. All right, with that, thank you, and please enjoy. Ask lots of questions. Alex is all yours. Thank you, Alex.
Thank you very much, Jan. Appreciate the introduction. So if you wonder who of the three that you see there in the picture, that's me. Just quickly raised the hand. To my right is Michael Demen and Christian Seine, far to the right. They are both helping me in the support of doing this webinar today, which I very warmly welcome to. Thank you very, very much for attending. I appreciate to see so many participants for today's webinar. I also would like to thank my colleagues who are obviously helping me to set this up and making sure that everything is working in the background smoothly. So let me jump right in and share my screen so that we can start with the presentation. And if I'm doing everything correctly right now, I will be doing this in the screen mode and have the opportunity to duplicate the slideshow. And now, with the confirmation of my colleagues, you should be able to see the full screen. So as Jan said, my name is Alex Viechter, which is probably more internationally pronounced. He already introduced my role within the USP, and today I'm going to speak about the qualification of dissolution testers with the assessment of our standard called PVT, Performance Verification Testing. And before you do that, you have to go through several steps, which I'm explaining as well. Unfortunately, this webinar is going to be very short. We usually have 1 to 2 take classes that go more into depth with the typical fundamentals in dissolution, and also the variables in play that dissolution is often giving us challenges with. But I hope with this very short time to be able to give you a glimpse. And if we see each other again, maybe in a future opportunity with a full course that we are offering, that would be even perfect. For the sake of giving you an understanding already regarding the slides, unfortunately, we cannot share these slides. They are part of an educational program, which we are allowed to use for the webinar's sake, but we can unfortunately not hand them out, so I hope you understand. Again, let's dive into the outline for today's webinar is to discuss from the general chapter 711, Dissolution, the apparatus 1 and 2, because they are essential part of the qualification using the PVT test procedure. Before we do that, we're trying to identify controlling sources of variabilities that play tricky roles in the performance and release of certain drugs, specifically with the prednisone tablet, as they are designed to be variable, so that you can detect the sources of variability when coming from the apparatus. The qualification of the dissolution test is where we start with the simple AIOQ principle, which is defined in the general chapters for instrument qualification, also in the USP. And then we go into more details with the performance verification test, PVT. So the goals in general for dissolution, the goals are, varying obviously from what you aim to do with the dissolution itself. Obviously, for those who want to identify changes in the formulation of the processing during the product development, they will see certain benefits that coming from a rightly equipped and qualified dissolution tester. Differences thereafter that could be assessed and further updated into the drug development. But if you want to also assess the drug performance during manufacturing as an in-process test or a batch release test, dissolution is the ideal quality and qualification test to go for. Variations in the manufacturing process can have critical influences, obviously, that you would be able to, review with the performance of the dosage form that is used for this particular test. And the link to bioavailability studies, if you want to compare an already available market product to, what you would do then in bioequivalence for the drug formulation that you are in developing procedures. The apparatus 1, we call the basket tester. It is comprising, like the apparatus 2, the paddle tester, of a glass inert transparent material, which usually, is clear. We have also seen some amber coated glass material in case, your drug product is light sensitive. But in most cases, it is glass. If glass is an issue, or if you think the material in terms of handling and cleaning is not the right thing, an alternative to plastic vessels is seen as well. All are comprising of a hemispherical bottom, which means it's a half round of a bowl. We know from the general chapter vessel sizes of 1 liter, 2 liter, and 4 liter, whereas a 2 liter is just an extended version of the 1 liter in terms of height. The 4 liter is also wider. The basket that is used here comprises of a 40 mesh wire opening that can be gold coated. Again, it is stainless steel, electrolytically polished. So from that point of view, your drug product should not actually go into a chemical reaction with the material that it is exposed to. But if stainless steel is an issue, gold coating will be accepted by the general chapter as well. The steering for the typical tests given from the rotating steer and motor assembly. On top of all that, we know of test procedures in monographs that typically have 50 to 100 RPM. The dosage form for the basket is placed obviously inside, which has some pros and cons. For material that if you introduce it into the vessel that is floating, you would have, or is buoyant, you would have an opportunity to keep the dosage form immersed all the time, so that material is not coming up to the surface area of the media top, and is also giving you a more constant release characteristic. Sometimes there are drawbacks with drug formulations that are falling into very, very small particle size below, the 36, 44 millimeter wire opening. That means that material could flush out, particles could flush out of the basket that still contain non-dissolved active principle, and that fall onto the bottom, and there it actually doesn't really do a good and reproducible job in releasing the drug product. For the paddle assembly, we use the same glass. Instead of a basket, we use a paddle that is attached to a shaft. The same inert material is used here. We are also allowing the opportunity to coat it either with Teflon, or there are even shafts and paddles available that are fully out of Teflon material made. Agitation with those methods used with the apparatus too, in the monographs that we see, are typically around 50 to 75 RPM. Now, the sources for variability from a dissolution test system in general may result from its environment, obviously, where it is placed. So it would not do good use if you place the dissolution tester on a unstable table, for example. If you have nearby equipment, that because of their machinery and because of their design are, applying variations in terms of vibration to the table, which will be picked up during the dissolution test in the dissolution tester itself. So the devices from the dissolution testers play a typical role. Ourselves, when we do the sampling and the processing, the filtration, dilution, and transfer, we can play a critical role. This is not performance related of the dissolution tester, but we have to consider that these are variabilities in general when doing dissolution tests. We will talk about filtration and sampling at a later stage. Transfer of media is probably a good thing to talk about too. And the details of the testing procedure. You have your validated procedure. You follow those validated procedures from A to Z. So it is the case with the PVT. You have a test protocol that you ideally follow, very close to what it is required, and only then you are really able to assess any results that you obtain from that PVT test to the certificate that is giving you, the ranges and limits of what you are supposed to achieve. The analytical instruments that are used on top of the dissolution tester obviously play a certain role. As I said before, we all have, our daily moods and daily, stresses and so forth. So ourselves as analysts have to be very careful that we, in a very reproducible way, do the testing on a common basis. Now, last but not least, the specimen itself. I mean, every tablet, it's a formulation, including the one for prednisone PVT tablet, has its inert intrinsic variability. But I can assure you, when it comes to the prednisone tablet, in terms of weight variation, content variations, we have very, very strengthened and narrow specifications for the manufacturer who is producing the PVT tablet. I thought it is a good idea for you to show or understand the fluid dynamics that are happening during the test. What you see on the left-hand side is a top-down bird view a circulation of a typical apparatus to steering blade assembly, you see obviously from the heat map itself that, you know, the colorful it gets, the closer it is to the shaft outskirts that are, you know, in the highest in terms of hydrodynamics. To your right-hand side, you see the vessel with the shaft assembly, with a paddle here in the same sense. You don't see the paddle left and right, it is in rotation. But what you can see here is the more orange or the more red it is, you see more turbulences, more energy, more agitation than anywhere else. And what's interesting, if you look at the bottom of the shaft where it is blue, this is a zone where actually not much in terms of hydrodynamics is happening, which is where you usually have your tablet, your capsule, or whatever is placed underneath the paddle. So imagine if you are in a situation where you are forced to dissolve active principle from a dosage form where it's seated and not really well agitated, probably the release rate is a little lower as if it were anywhere else in the vessel placed. So considering that fact, for some of the developers in dissolution methods, this plays a critical role. Some of them are even using peak vessels, which means, you know, in the development still possible, you can use vessels that have kind of a glass peak or a glass bowl or whatever, just to distract, you know, the specimen to be sitting underneath the shaft and be exposed more to energies and fluid dynamics around that. Again, as I said, for development purposes, that is a great thing. If you want to start seeing some early results in terms of the release of the drug formulation, that's fine. For routine and quality control batch release, this is no longer a dissolution vessel specifications that you use. As far as I am concerned, I haven't seen any monographs or any approved products from the FDA or other authorities, but I might be wrong there. So not only for the agitation here, but also considering when you take the sample, it is actually meant on purpose that you have to take a sample, how it is described in the general chapter 711, in the zone midway between the media surface and the paddle top or the basket top, at least 1 centimeter from the vessel wall. Because with 50 RPMs and, you know, only 30 minutes in the case of PVT or any immediate release drug product, or let's say slightly modified who have a longer release characteristic, you will see, you know, differences in homogeneity, in concentration, eventually, especially with 50 RPM. So it is essential that you take the sample at a spot that you define on a regular basis at the same spot throughout the whole tester assembly, whether it's 6 vessels, 7 vessels, or 8 vessels you have in place. The specifications for drug release are based on 6 or 12 or 14, depending on the design of your instrument. But again, my aim here, my point here is to be reproducible with the position of the sample that you are taking. So this is very interesting, and of course we can go there into much more details. I am not the scientist and I'm not experienced enough to really tell you the details, but I thought those big ones that could contribute in terms of variability. And by the way, those of you who have witnessed the performance test already once, when the tablet starts to release, you know, the first couple minutes when, you know, the tablet breaks apart down here, you see some material floating at the beginning, but suddenly then after, you know, 5-6 minutes, everything starts to relax and the material comes down to the bottom. But what is shaped is this kind of a peak. And this peak for PVT is wanted. You know, you want a reproducible surface area throughout the whole 6 vessel assembly to be able to have controlled release of the specimen in place and be able to extract any variability that may come from, you know, the surface area that is produced by this peak. If the peak is not formed the way you are used, you know, this powder peak, if it's kind of left-shaped, right-shaped, or it is flat, these are all indication that something is going on within the tester itself. So our experience has shown that the more flat this peak is, the more vibration you have, either coming from the dissolution tester itself, the motor, steering elements, circulation pump, or whatsoever, or nearby sources. In the worst case, you have a centrifuge apparatus just next to the dissolution assembly that is really applying vibration to the tester. So you will see differences in results if just only by visually looking at how this shape is occurring, and whether it's left-centered, right-centered, flat, or whatever. In our experience, you can immediately stop the test because you will have variances in results. How big? It's a question mark, whether it's still, you know, adjustable, up to you to define. But as a variability, I'm giving you an alert here. This is essential. So, but before even doing the PVT, we are looking at the instrumental qualification, the AIQ. And we have a chapter for that that is called 1058, which is an informational chapter. All chapters above 1000 are for information purposes only. They are not regulated, nor are they enforced by the FDA, or shouldn't be by any other competent authority. Everything below 1000, so in the case of the general chapter 711, this is a mandatory chapter. So if a monograph that contains a dissolution procedure or a dissolution test that calls out for the dissolution test to be done according to 711, it's a request to do that. It's mandatory to do that test accordingly to 711, and 711 also describes the qualification of the instrument and is calling also for the system suitability or the performance verification test, PVT. But the analytical instrument qualification starts out with the DQ, design qualification. Installation qualification is next. Operation qualification is the prerequisite for a performance qualification. Operational qualification, OQ, what you also understand as the mechanical qualification. There are basic requirements coming from the general chapter 711, but ASTM and other guidelines are extending these steps and even narrowing the specifications to what you know from 711. Because remember, the general 711 has been developed many, many years ago with dissolution apparatus that have not been designed the way they are engineered today. So everything is much tighter, much smoother, much, much better. For those testers these days to comply to the standards in 711 is a given. So narrowing down the specifications for up-to-date equipment is only a logical procedure. Having said this, this is all fine, but this alone wouldn't give you the whole story of the performance of the dissolution test. So that's why we do on top a holistic test, a so-called umbrella test, which is the performance qualification that makes sure that everything, you know, that is applied to the dissolution tester is working in accordance. The design qualification for you is a typical thing at the beginning before you buy an equipment or before you use an equipment that you already have for a new project, you know, or you continuously verify whether the purpose for this dissolution tester for the test that it is, you know, addressed for is still good. So you describe everything, the parts over to whatever it is required to be doing so it successfully is doing the dissolution for you for the drug product that you are assessing. The instrumental qualification is essential, especially when you have a new equipment. You would want to check every single part that you obtain. There are manual checks that you can do. There are visual checks that you can do. All equipment, all accessories supposed to be delivered to you according to the specifications of the General 711, and you usually get a certificate of compliance from your supplier. I encourage you to check that. Don't take this for granted. Check it, please, again. Especially, you know, with the vessels. They have a very wide, I would say, specification. If you look at the inner diameter specs for a vessel, a 1 liter vessel, it's 98 to 106 millimeters. So that's almost a centimeter variance that you have from a small vessel to a larger vessel. And if you go back to that fluid dynamic picture that I told you before, the variations, if you are at an extreme small within spec vessel or an extreme wide within spec vessel, the variances, and we have shown this in studies, can be different and can make a marginal difference to your dissolution results. So please check your equipment, your accessories under IQ before you assess them with the mechanical qualification. A thorough mechanical qualification is important. And with our recommendation, before every PVT should be done again. There are customers who are doing the PVT on a yearly basis, other on a 6-monthly basis. We always recommend, you know, how many times you have the equipment in use, how many batches you are releasing. That should qualify for the number of the qualifications that you are doing. If you have a dissolution tester that, you know, releases batch, let's say on a regular basis, it may satisfy, you know, to do this on a yearly basis. But if you do, you know, several batches a day, for example, which is obviously the other extreme, just think of the fact that, you know, as soon as something goes wrong, you know, and the dissolution tester is the faulty part of your drug product that is released not in the right way or is giving you results based on the performance of the dissolution tester, not on the formulation. You identify this as an issue. How long ago or how much time ago has this started to go wrong already? And how many batches are in question that you have released based on this dissolution tester that you have now identified to be faulty? So the more regular you do the PVT test, the more insurance you have, you know, that the tester is really performing over the period of time that you have it in use. Why is PVT a requirement? As I said before, it's a holistic test, and it really, you know, encompasses all the metrological parts before that you do, but is giving you a holistic answer of the test performance. It's also an ability to uncover influences of unforeseen system variabilities in dissolution testing. The PVT is doing all that for you. Ability to compare intra and interlab variations. You can use PVT to do that. Method transfer, for example. If I want to mention just one way of doing. PVT is a globally recognized method for dissolution system. US Pharmacopoeia is the only pharmacopoeia that describes a specific formulation with specific test procedures. Other pharmacopoeia do recommend you to do a similar system suitability approach, but you are left there with your own interpretation on what to do with PVT. And our way of giving you these type of recommendations and trainings, I think you are in a safe side in applying the performance assessment for your dissolution tester for various requests from various competent authorities. Just before I dive into a little bit more in detail with the PVT itself, you can find lots of resources on our website as well. Lots of videos, lots of descriptions. We have a toolkit there that not only describes the essentials of the PVT, but the dissolution tests in general. We show you how to effectively degas the medium if your drug formulation is required for a medium to be disgassed before you put the formulation into the media. For PVT and the drug product prednisone tablet, it is essential to degas the media beforehand. And now you're telling me this has nothing to do with the performance of the dissolution tester itself. Right, you are. It is not related to that, but it is related to the sensitivity of the formulation itself. That is releasing the drug differently if the media is degassed or not degassed. And the test protocol to do the test will ask you to degas the media. All those laboratories that helped us in the collaboration to establish the specifications have been doing this test. So the results obtained, the specs obtained, have been on the basis that every time the media was disgassed when the test. So only when you also degas the media, you can really compare your results against the specifications. The certificate of the prednisone tablet, I hope this is the current one. Yes, it says September 30, 21. The current tablet formulation with the lot R08OJ1 can be used until September 30, 2021. And the last one that was in place actually expired just a year ago. So this is a year of expiry that this particular lot can be used. And if you look at other reference standards from USP, this is the only real reference standard at USP that has an expiry date applied, but it's also the only formulation as a reference standard. Everything else is an ingredient, either an excipient or an API. So there you have a protocol. You are asked to follow that to the point, how you discuss the dissolution media, the procedure itself. And I really encourage you to follow that by heart. The gassing of the media, as I said, is essential. You would heat up the medium while gently stirring here at the left-hand side up to 41 to 45 degrees centigrade. Why at that temperature? Because after you apply the medium with vacuum, when you pull it over into that red flask through a filter mechanism, and at 100 millibar vacuum, the temperature around 41 is simulating 100 degree, which is usually the boiling point of water. And the boiling point of water would be the ideal scenario to degas medium. But nobody's doing that because waiting for the temperature to come down to equilibrate the medium again is not what you want. So what you can do is simulating the boiling point, because the solubility of gases is nearly zero at that temperature. So you simulate that procedure. And the other positive aspect is that once you transfer the media directly into the vessel, because you have a gravimetrical method to do that, or you put it first in a measuring cylinder, in a cold or room temperature measuring cylinder, you will actually cool down the medium quite a bit before it's actually placed into the vessel. So consider the drop of temperature that you have, because you would want to start the test with an degassed medium immediately, so that if it's exposed to environment, the medium will not re-gas or rearrate again. So you would ideally define a temperature at the degassing of this medium that you know when you transfer the medium has exactly, or let's say plus minus 0.1, 0.20 degrees centigrade, so that you can immediately start with the test. There are other deaeration procedures. This one is used for the PVT, and we encourage you to do the same thing, not only because it is very efficient, but it's also very inexpensive and probably can be used anywhere. What you will achieve when you do this test, this medium degassing, is rest oxygen concentration of about 4.5 ppm. Everything that is below 6 ppm will stay in terms of results. When you look at this chart, the left-hand side percent dissolved and oxygen concentration to the right will result in the normal, after 30 minutes released concentration of your sample prednisone. As soon as, the ppm level of dissolved oxygen is going above 6, you will not only see much higher results, but the variation of these results are much higher. So a medium non-degassed with prednisone will give you between 70 and 80% released after 30 minutes, which is double the result. So no wonder why it is critical to do the medium deaeration here. When you do the basket test with PVT, it is essential to dry the baskets and to put the tablet into a dry basket. Why? Not only the prednisone formulation is sensitive to degassed medium or non-degassed medium, it is also sensitive to picking up moisture. The longer you expose the tablet when you take it out to a blister, to environment, humid conditions, or even to a wet basket, the more different your results are going to be. So again, for the sake of reproducibility, make sure that your baskets are all dry and you put them into the tablet into a dry basket before you immerse it into the vessels. You can do an immediate start by introducing all six baskets at the same time, but you can also do a staggered input and then accordingly take the samples to the time differences to which you have inserted the baskets to. Timing is important because remember, when we take a sample after 30 minutes, the prednisone tablet has only released about 40% of its whole content. So it's in the verge of that dissolution curve going up very shortly. So the time tolerance of plus minus 2% at 30 minutes, which is 36 seconds before and after 30 minutes, you need to take the sample of all 6. If you have a 7-station, 8-station dissolution tester, that you assess those stations as well with PVT, the time gets even shorter. Hence, the recommendation to do it staggered as well. With the paddle, again, you allow the tablet to fall beneath the paddle blade. The paddle is not supposed to be moving when you introduce the tablet. The whole assembly is not supposed to be steered for equilibration purposes or whatever, because you want to start, especially with the paddle, with reproducible start conditions. So you have the medium, and again, it's also important what I said before, the medium degassing temperature that you have defined, and the transfer that gives you a final temperature at the vessel should ideally be met at 37 degrees centigrade so that you can immediately start. If you start to equilibrate the medium again because it has fallen below 37, or you need to wait for the temperature to come down, imagine what happens, especially for high head systems that may have covers or not. The exposure to environment, air conditions is huge, rearrangements can happen, and the success of having the media disgassed is fading away. But also the paddle is not supposed to be steered, because when the tablet is falling down, it potentially could be hit by one of the blades and could crack or fall apart, and hence the disintegration part is much faster, and the mechanical lag is different than from that one that was hit by the blade to the other ones that are in place. So again, when you think of the coefficient variation, that could be an instrumental part. Sampling is very essential as well. We recommend you to take as much as you can into a syringe. 30 milliliter is what we describe here, 20 milliliter at least. Do not apply a filter to the syringe when you take the sample. Apply the filter once you have taken the sample and push through a certain aliquot, 2-3 milliliters, discard that, and use the rest that you are filtering for the analytical part. Why? If you are attaching a filter directly in line by taking the sample, remember you have undissolved particles in the vessel. You might potentially pull in particles with undissolved prednisone active principle, and through the filter and the turbulation, you will expand the dissolution to it. It is also recommended to immediately after filter the sample, because what happens if you have undissolved material in your syringe and at the temperature of 37 degrees centigrade, it will statically continue to release drug. So again, you will not have the real result of that aliquot that you have taken right at the time of 30 minutes. That's basically what I said about filtration. The specifications are based on ISO principles that were defined many, many years ago. You have now a range of acceptable geometric means, plus minus, and you have only an upper limit for the percent CV. Both have to pass. The certificate allows you to perform the PVT either at a single stage, or let's say the requirement allows you to do it at a single stage or optional two-stage test. And for both tests, you have specifications within the certificates to your right. Single stage means for a 6, 7, or 8 position test assembly, you do one test with 6, 7, or 8 tablets, and you do a consecutive test of again 6, 7, or 8 tablets, and statistically calculate the geometric mean and percentage CV based out of these 12, 16, or 13 or 16 test results. And what you are having to meet is up here. If you have a 12 or 14 position tester, a large equipment, you only have to do one test within that single stage test and apply all the 6 results or 14 results that you have to this specification. This is for apparatus 1 and apparatus 2. The optional 2-stage test means that you do one test, and for that allowance to stop after the first test, you have different acceptance criteria to the right. If you compare, you see they are more narrow. This is actually the penalty that you have if you decide to go for that optional 2-stage test. The results have to be more stringent, more narrow, as well as for the GM, geometric mean, and the percentage CV. Down here, you have a futility factor test that can be applied actually to both single stage and optional 2-stage tests. If you receive results, from a 6, 7, or 8 position vessel, a percentage CV that is 16 or higher, for the paddle 11 or higher, then you can immediately stop the test, because with the second run, you will not come into the specification. So this is just for you to avoid going through a second round. If you have such results, obviously something terrible is going on that you need to assess first. What that is really, a thorough procedure to find out. We have on our homepage an Excel file, a dashboard, or a spreadsheet that is available under our toolkit, where you can quickly, run raw data and get some results for your immediate visual. This is not a validated Excel file for your routine purposes. If you want to do an Excel spreadsheet based on the calculations and equations as provided in the certificate, you have to validate this your own first. Troubleshooting. I failed my PVT. Now what? The data fails the geometric mean. So it's usually high, but passes the percentage CV requirement usually indicates that something is affecting the path with the positions of the tester in a similar manner. That means that, for example, you have not properly degassed the medium. External sources like vibration could be the part. You know, if you use the dissolution tester in an automated procedure by introducing the tablets automatically or taking the samples automatically, consider this to be a variability, because none of the labs that have done the tests for us in a collaboration to establish the specifications are supposed to use an automatic procedure. Procedure is based on a manual equipment. Everything is taken manual, hence the results are only to be compared against the same procedure. If you assess this with an automated sampling procedure, you first have to verify whether or not you are within your self-defined within or out of range specs for the same system with devices and assemblies to be qualified as such. Errors from the standard solution absorbability could be an issue for high geometric means. If the CV fails high, obviously, then it could be an indication, as I said before, the vessels, despite they might all be within the acceptance criteria, if you use a range of vessels that qualify but are varying in terms of design, that could be an indication. Vibration could be a source and issues for other specific components. But again, this is really just, you know, a very, very general and small indication of what could go wrong with your dissolution tester, nearby sources or analytics. There are more details explained on our website as well. But as I mentioned before, if you ever get a chance to do a course with us, we go into much more details from that. Conclusions. Recommendations is follow the protocol. Make sure you read the certificate. Do this step by step and you are fine. Designated vessels mean keep the vessels always at the same position. If you always switch them around and you don't really know which vessel was at which position at a test, even at your regular routine testing, and something goes wrong, specifically within the PVT, you don't really have an opportunity to assess the vessels as a faulty part because they've always been at a different place. Rigorous mechanical qualification, again, is really essential, but it doesn't tell you the whole story. Proper deaeration of the dissolution medium might be critical for certain drug formulation. It is critical for the prednisone reference standard tablet. The test should start as soon as possible after media deaerations. The reasons I've given to you, reaeration is possible, and you have not reproducible start conditions for all vessels. Why the filtration of the sample immediately is important. Again, we only have taken a sample after 30 minutes where only 40% of the active principle is dissolved. So potentially we might pull undissolved material into the syringe, where, at which it can continue with a certain static dissolution, and results filtered an hour after the sample has been taken may give you different results. I hope you have been able to capture my email address, especially if you are residing or working in EMEA, which our office is responsible for, so I can address for you any questions related to the solution if you like. The general mastermind, or let's say guru, or you know, however you want to pronounce Margaret Marcus to be, she is responsible for all drug product monographs in all monographs that we have at USP. She's responsible for the general chapter 711, 724. She is, you know, working with our expert committees on these chapters. Not only that, but also she has the column database. Margaret Marcus is the person that you would want to go to for any type of dissolution questions that you have. So mark her email address, mrm@usp.org. If you ever have an issue with reference standards in general, or in this case with the PVT, please send your email with the technical concern and question to rstech@usp.org. Why? Lisa Corbin, who is managing this email address, is funneling all requests, all concerns, all questions in one database, and so will be able to identify any issues occurring from reference standards if they are coming in on a multiple basis, which is a good indication for us to make sure we maintain the quality of the products. So with that, I am a little bit over of what I promised to use as time, but I hope we still have an opportunity to go through questions. Thank you for listening. I hope this was interesting for you. I stay available for the questions that you have.
Alex, we have several questions in the chat box and the Q&A. So I will, what do you prefer? I will formulate it by voice or to send you in the chat message?
If I open the chat myself, I see from Marta Mullins, from Tunde Zislak, Samuel Kuzi, I see questions. Are these the questions that you are referring to, or do you see more?
That's correct. Also, Konstantin Virlan has asked us.
Okay, so let me read the first one. To ensure a good fluid dynamic in vessel, what do you recommend about sampling probe? Should we perform the test with the sampling probe inside the vessel, or is it better to introduce it at a sampling time? The latter, please. Please introduce them at the sampling time, because any other device that is inside the vessel during a dissolution test will cause you trouble in terms of variances. Not all dissolution procedures are affected and are sensitive by that, but definitely the PVT is. So remove the sampling probe while you do the test and only insert it at the time of sampling. Next question, we perform preventive. Is it correct to perform MQ twice a year and PVT one a year when we perform the preventive A? There is this general recommendation of USP that, you know, you have to look at it from the number of tests you do with this test equipment. If you think once a year PVT is okay, this is really up to you to define in your SOP. Doing the mechanical qualification more often really makes sense. Sorry, I sent the question by error. We perform MQ twice a year and preventive maintenance once a year. When one of the MQ is performed, is correct to perform only once a year after performing the preventive maintenance. So I would always do the MQ before, if that's what you call preventive maintenance. Yes, twice a year is definitely a good start, but again, look at the amount of dissolutions that you do with this equipment. You know, how many different people are working on the dissolution equipment itself, how often you have to replace accessories because of, you know, the speed you have to perform these tests too. And, you know, we all know that the more stressed we are, the less we take care of any accessories that are in use, which we actually should do, because cracks in vessels or irritations in vessels that are coming from a wrong cleaning procedure, or, you know, baskets that are worn because, you know, we just drop them into the sink, clean them, and they get bent and whatever. So I would really recommend to do the mechanical qualification as often as you can. Can enhanced mechanical calibration replace PVT? Not in our opinion, but that's for everyone else to design. Again, PVT for us is a holistic test. You can do the mechanical calibration, which is an assessment of all tolerances that you test against with a mechanical assessment device. You can confirm that it is within specs. But when you actually look at studies that we did on a maximum exposure test. I don't know how to call it in a different way, but there is a study from us where we have done several tests where we used vessels always in the extreme within the specs of 98 and 106. We have tilted the shaft slightly, so it's still okay. So we have these done tests against each other with different exposure variations, and we have found variabilities, especially for vessels and devices that are bent, that can contribute to an overall change in geometric mean and coefficient variation. So if the mechanical calibration is telling you that everything is within spec, it still doesn't tell you how, statistically these contributions, these potential variations are meeting as an essential role within the whole test description of assessing 6 tablets, which is what you have acceptance criteria for in your monographs. Hi, please I joined the event late due to internet connectivity. Could you please share with me the video recording and the slides? The video has been recorded, and as far as I understand, will be the link to which will be sent to you soon after we are ready with publishing the recording. And I think YouTube, if I remember well, is what we use there. The last question that I can see, can we change % recovery acceptance criteria in exceptional cases like oil-based formulation in the dissolution method? For the sake of the topic that we have discussed here, I wouldn't want to go into that into detail. But we can take this offline, or you can contact directly Margaret Marquez, who is much better qualified than I am to answer questions like this. If there are any other questions, please let me know. I'd be happy
Alex,
to. We still have some time.
Yeah, let's have one more question from the question and answers box that we see here. The question is, the questioner asks that she has done a 2-stage PVT in 5 equipments, and all of them failed the pedal test, but they all passed the basket test, and all mechanical criteria were also met. What do you think about this? What can be the reason for failing of the pedal test? I think that's pretty much what you just explained also before, and what was discussed with the fluid dynamics in the presentation. But please, can you maybe expand once more on that?
Difficult to say from a distance and without looking at the results. But if you look, normally it is the basket test that gives you a heartache or challenges. And the paddle test is less of a situation because the conditions are much more controlled there, and we use this type of apparatus in a more routine basis. But if you are remembering what I said before regarding the hydrodynamics in below the paddle, with the paddle test, the formulation is sitting underneath the paddle. What I recommend you to do is to look at the behavior of this prednisone tablet while it is disintegrating and how quickly it is forming that particular peak. And if this is consistent throughout the 6 vessels, and similarly to be seen with the other dissolution equipment as well. That could be indicative to eventually how you do the medium degassing, and maybe look at the performance of the degassing procedure there. But it also could be what I said before, are these dissolution testers placed all at the same bench? Do we actually operate them at the same time when we do the PVT, hitting on the bench, working with other equipments while this test is running, is all applying vibration, and the extent of vibration as minimal sometimes it can play an important role. But again, from distance, it is really difficult to assess that. But I would start with investigating on the points I just described. Medium degassing and vibration.
Okay, I think we have some more questions, but we are already up to the hour. But we have a protocol and we'll try to answer the questions. If you still have questions and you feel your questions were not answered, then please reach out to us again. But I think with that, we are ending the Q&A session and hand over to Jan again.
Yes, thank you very much. I'm sorry, we have to be on time. We need to close. If you have any questions, please forward them to us anyways, and we'll try to get back to you individually. Just a couple of more quick updates before we go. We have a number of other webinars lined up for you. Next one is going to be on 11th of May by Christian, who's here with us today. It's called What You Always Wanted to Know About USP Reference Standards. And then we've got the next one on 20th May with General Chapters by Dr. Rossio Papa. And please check our calendar on our homepage, www.usp.org, where you will find a calendar with all the other webinars we've got lined up, as well as educational courses and other events. If you go on our homepage, you will see on the top right side a tab. It's called Events and Training, and there's the calendar. All right, well, thank you so much. Christian, do you just want to maybe just share a quick line about your webinar that's coming up next for those who might be interested?
Yes, I can do that quickly. So that's in 2 weeks, and we will talk about the process, how we set up, why we set up reference standards, and how we set up reference standards. That will be included in the presentation there. Yeah, that's it in short. Yeah.
Okay, perfect. Thank you so much. All right, everyone. Well, thank you. We hope you had a great time. There will be a very brief survey afterwards. If you'd be so kind, just take a minute or two to please give us your feedback. We really appreciate it. And yes, thank you again to Alex for his webinar. Hope you enjoyed it. Mihail and Christian as well. And yes, hope to see you soon. Please take good care and stay safe. Thank you.
Thanks, everyone.
Thank you.
Later. Bye.
Bye-bye.
Bye.